Okay, level 1 exercise here. So the first one is find the range of values for which this is an increasing function. So in terms of fx, I kept it as fx. There's no f dash x, differentiate it. It's increasing when f dash x is bigger than 0. So that's just straightforward. Number 2, find the range of values for which it is a decreasing. So it's exactly the same. F dash x, remember that is dy by dx. Put it under 0 and solve. And just remember, when you're changing all signs, you change the inequality as well. Question 3. This is where it's getting awkward. So I have drawn out the original graph. And so it says, yeah, you have to match them up. So here's the original graph here. So let's see what's happening. On this bit, it is negative. So the gradient is going to be negative. It's got one turning point, so it crosses the axis once. The green line is the gradient is positive, so I'm above the axis. So negative beneath the x-axis, turning point on the axis, increasing above the x-axis. So let's look at this one. Increasing, I'm above the axis. It hits the x-axis and then it goes down, decreasing. So above the x-axis, hitting the turning point beneath the x-axis. So increasing is above, turning point is on the axis, and green, the decreasing, is beneath the axis. Now, this one here, there's a constant gradient, so it doesn't change. It's the same gradient throughout. So it's just a straight line graph, because the gradient is the same throughout. This one here, we're going down, negative, so we're beneath the axis, on the axis, so beneath, on, and then we're increasing, so we're above the axis. And the next question we've got to look at is question 4. And the first bit of it is, you've got your graph, differentiate it, find the turning points. So set dy by dx equals 0 and solve. So it's a quadratic. Factorize or use the formula. Get your x coordinates, sub them into your y to get your y coordinates. You've got your 2 points. Then you've got to find the turning point. Now this is a strange one. Sorry, find the gradient of it. Sorry, find the nature of it. Normally I would just do second derivative and then sub the x in and do it that way. But they're asking you to consider the sign. So what works through their way? So turning point is there. Before the turning point, so for example, x is minus 4. See what the gradient is. The gradient is positive. After the turning point, so let's try a different point. X, say for instance, x is minus 2. The gradient is negative. So it's positive before the turning point, then it turns, then it's negative. So it's a maximum turning point. But as I say, if you're not asked to do it that way, do the second derivative. So if you were doing the second derivative, you would have 6x add 12 and then sub your x in. So it will be 6 times minus 3, which is minus 18. Add your 12 is minus 6. So it's a negative second derivative, which means it's a maximum turning point. Now let's have a look over here at the other turning point. So try before it. So for instance, x is minus 2. Work out the gradient. You'll put it into dy by dx. The gradient is negative. After x is minus 1, so for example, x is 0, the gradient is positive. So it's negative before the turning point, then it's at the turning point, and then it's positive. So it's a minimum. But as I said, I would use the second derivative for that and sub in x is minus 2. And then sketching the graph. And that is your work for level 1.